Awesome. Recording started. Okay. Um, Hi, everyone. Welcome to the Dapr Community Call number 67. My name is Nimira Uversky. I'll be your host for today. I'm a contributor from the community, so super excited to be hosting you guys today. So for today's agenda, we have a lot of different items. So we're going to start off with a DaprCon update, go into a few workflow demos. We have a pub sub for actors demo, and then we're going to be closing out with an actor exception handling demo. I'll go ahead and get us started with our DaprCon update. Okay, so update on DaprCon is, so the submission deadline for CFPs is officially closed. That said, if you do have a CFP that you still really want to submit this week, go ahead and reach out to me directly on Discord, and I can talk to you about, what we could probably do to accommodate you. But for the most part, open submissions are closed unless you message me directly, or I've already discussed with you your specific circumstance. Just as a reminder, DaprCon will be on Tuesday, October 25th. And just so I say it explicitly, to attend DaprCon, you'll actually have to be attending KubeCon. So you'll have to actually purchase a KubeCon registration. And once you do that, you should be able to go ahead and attend DaprCon as a pre-con event for that. If you want to go ahead and register for KubeCon, there's details here on the link. We'll share the slide deck afterward, or you can just go to the KubeCon North America site to register there. Okay, and that's it for me. So next up, we have a workflow demo from Chris. Chris, do you want to go ahead? Do you want me to share your slides and then you can share for your demo, or do you want to go ahead and share the deck?
Why don't you share the slides for me, and then I'll take over for the demo part.
Sounds good.
All right, so hi everyone, my name is Chris. I'm a software architect at Microsoft, focused on the Dapr workflow project right now, amongst other things. And in particular, I'm going to talk today about the workflow engine that was submitted as a proposal in the Dapr repo. You can see the link below. But what we're going to talk about today is the proof of concept for this workflow engine, which sort of precedes the full implementation, which we're going to be getting into next. But anyways, the goal of the proof of concept is to rapidly produce a reference implementation using actors and using the durable task framework for .NET. This is, we're going to prototype a Dapr workflow runtime SDK as well, and just sort of collect feedback. And the goal, really, the fundamental goal, is to create confidence in the design before diving into the Go implementation, which there already exists a .NET version of the durable task framework. And so as part of the actual Dapr workflow engine that we want to build, it's going to be a Go implementation that's able to be loaded directly into the Dapr sidecar. But anyways, yeah, this is mostly about building confidence and sort of exploring the space before we go into the full implementation. And then non-goals would include shipping this proof of concept and incorporating the workflow building block APIs, which Ryan is going to talk about after me. That's out of scope. Next slide. So as part of this presentation, I'm going to be showing an order processing demo app. We could see the architecture of it here. The ordering service this is basically a microservice that involves workflow. There's sort of a web front end, and there is a variety of other support services as well. We have a payment service, an inventory service, and a notification service. These are written in different programming languages and all using the Dapr sidecar to sort of communicate with each other. We use service invocation and pub sub as well. And the ordering service itself is going to be a combination of a web API as well as a workflow application. And we're going to dive into the code of what that looks like shortly too. Next slide. And then just to sort of give you an idea of the target architecture for the Dapr workflow built-in engine is this top diagram here, where you could see there's Dapr sidecar, and then there's going to be actors running in. Actors are sort of the underlying mechanism for implementing workflow. And then you can see on the right-hand side there's an app container, and then it uses a workflow SDK to talk to the sidecar to sort of implement the workflow. And on the bottom is what we're actually going to demo today. This is basically the same architecture, except the workflow engine is split off into its own little yellow box, which then talks to an unmodified Dapr sidecar. So with that, why don't I go ahead and share my screen so that we can actually jump in to the demo. And if I can just figure out how to use Zoom. Okay, great. So what I have here is a Visual Studio Code set up with the full end-to-end demo that I have. There are a couple Dapr components that I'll be using. It's actually all just the default Redis setup. So I have a Redis for PubSub and also Redis for the state store. As I mentioned in the diagram, there's going to be a few applications involved in this microservice. There's an inventory service, which is just a Python app. It receives requests and just sort of dumps out whether the request was received. So these are very just sort of vanilla services, just kind of placeholders. We have a notification service as well, written in TypeScript. For the most part, this is where any updates in the workflow processing will be seen here. We're using the Dapr client SDK, sort of using that to talk to Dapr to receive those notifications. We have a payment service, which is also a Node.js app, which receives payments, and this is happening over service invocation. And then finally, we have a web API, which is actually a combination of two things, both a web API as well as a workflow. So this is where I'm going to be spending most of the time, is on this particular app. If you're familiar with ASP.NET, then this will look very familiar to you. We're just building a normal web application using the standard on .NET 6. One of the things that we've added in this proof of concept SDK is a method for adding workflow, and this is specifically adding the Dapr workflow capabilities. And then, so we're going to add that. I'll dig into what that means, but we're also going to look into some of the HTTP APIs that are part of this web app for submitting orders. But anyways, if we dive into what it means to add workflow, one of the things that you're going to see is we're going to offer a register workflow method. Workflows are written in code, and this is just normal procedural code. There's no sort of YAML or anything like that for defining your workflow. It takes a response, it takes an input, it has an output, you give it a name, and then you give it an implementation. In this case, it's just a function callback. And it's given this context object, and from this context object, you are able to invoke building blocks of Dapr building blocks. So for example, we have a publish event method, which calls into a notifications pub sub, which I showed you before. We're going to say we received an order. We're going to do service invocation as well into the inventory service and pass in some information about the order. The idea is that we get back some result from this invocation into the workflow, and we can basically determine, do we have inventory for whatever this order was that you got. If the total cost exceeds $1,000, then we have some additional logic to basically a manager needs to approve it. So this is a classic workflow scenario where we need some human interaction. And basically what we're going to do is we're going to publish a notification saying, hey, this requires an approval. There's a deadline for that approval, which is 24 hours. And basically, we're going to tell the workflow, hey, please wait for an external event called approval for 24 hours. Now, there is a mechanism for sending events to the workflow that the workflow can respond to. If we do not receive an event in the 24 hours, this API is going to raise an exception, task canceled exception, at which point we say the approval deadline expired, and we're going to return a result for the workflow that says processing failed. Otherwise, if we do receive it, we continue out of this block here and we move on to the next step, which is basically to set some status, publish an event saying, hey, we got the approval. And then the last step of the workflow is we call into a payment service using service invocation. And then we publish a notification saying the order was processed successfully, returning finally a success status. So this is the entire workflow that we'll be demoing today. So you can see there's lots of steps in here. We invoke various building blocks, in this case, pub sub and service invocation. And those are going to basically invoke indirectly these other services within our microservice app. And the way that I'm going to drive this demo today is using some web APIs that I'm exposing here. So there's going to be a web API for submitting an order, a purchase order. And this code, what it does is it binds into this workflow client object. So this is, again, part of the proof of concept of an SDK that developers would be able to use to sort of interact with the workflow engine. So in this case, we have an API for scheduling new workflows. Again, this is the process order workflow, which we've defined up here. It takes in some inputs, and we're going to basically just return a response back to the caller. There's going to be an API for getting the status of those workflows. Again, just we bind to this workflow client, and we're able to get some metadata associated with a particular order that we submitted. The order ID is used as the workflow ID. And then finally, for that approval action, which I showed earlier, we have a route just for that. And what that's going to do, again, we bind to this workflow client. We fetch some information about the workflow. We see, does it actually exist? Is it actually running? If so, we're going to raise an event, and that is going to trigger this line of code right here to complete. All right, and so why don't we go ahead and get started? So I'm going to, I have a bunch of console windows here, which we can switch to sort of see what's going on. So we have the notification service. That's probably the most interesting one to look at. So I have a bunch of requests. The first one that we're going to do is we're going to submit an order for some cat food. And we have a particular quantity and a total cost. This is under the $1,000. So if I send this request, we get back some information, and we expect that this is going to be approved immediately. In fact, if we look at the notification service, again, this is just using Dapr pub sub. We get a notification that we received an order. Here's its ID and what we received, and that it was processed successfully. So this executed the entire workflow all the way through. And in fact, if we want, we can go ahead and take this URL right here, and we can submit a new request to actually get the status of the workflow if we want to sort of look at it directly. And we can see we get back a JSON object that says, yeah, here's the instance ID, the workflow has completed, the output is processed equals true. Okay, so that's great. So that did exactly sort of what we expected it to do. If we check the inventory service, we can see that, yes, we did receive this request. The payment service, yes, we did receive the payment. So it looks like all of our microservices were invoked successfully by the workflow. So let's do another one, this time one that requires approval. So I'm going to go ahead and click send request for an iPhone. This one happens to be a bit more expensive. It exceeds the $1,000 mark. We send that request, and then we can see we didn't get a notification from the payment service yet, which is expected. We did receive the request. But if we check notifications, we see that, oh, it's waiting for approval and it has a particular deadline. Okay, so the workflow is doing what it was supposed to do. It's waiting for an approval. And then at this point, what we can do is we can take this URL, we can paste it in here and just append this approve. Once we send that, and we're going to see that the order was processed successfully. The payment service was invoked, and we did get that payment that was required. So anyways, so yeah, we see that this workflow is running. These workflows are resilient. So if any of the processes crashed and needed to be restarted, the workflow would pick up exactly where it left off before, which is sort of the magic of this implementation. If we had more time, we would do a few more demos, such as actually demonstrating the durability of these. I do have a demo prepared where we could order, some tacos, and we can crash the app and then sort of resume it and show that, we did actually get our taco order processed, which is good. And then as well as some other long running, like over 24-hour orders, we could demonstrate those as well. But for the sake of time, we're not going to do that. But anyways, point is we have this working so far, at least the proof of concept. The next step is to actually build this completely into the Dapr sidecar instead of having our own separate sidecar that talks to Dapr. So it'll be a completely Go implementation of the workflow engine itself. The programming model will be the same, at least for .NET. And of course, we'll have programming models for other languages as well. So anyways, that's it for this demo. Happy to take questions. Otherwise, we can pass it on to Ryan.
We do have one question. It looks like Mark has added a question into the chat. He's asking, where is state held in this example?
Oh, great question, and apologies for not going into that in more detail. The state is held in the configured state store. So in this case, my state store is Redis. Behind the scenes, all the workflow state is stored within an actor. So you don't see the actor here, but we're using actors under the covers to do that. And the actor is using the Redis state store to store its state.
Awesome. Any other questions?
I just have one comment. Hey, Chris, this is Yaron. It's really great to see this, from a maintainer's perspective. This really gives confidence that the overall design is going to work properly once it's integrated into the Go implementation. And also, it's really great to see that this leverages existing Dapr actors, which is, a building block that's been out there for a while. Now, there's two aspects to this, right? There's like the programming model that's going to find its way into the separate Dapr SDKs. And then there's a management API that can actually work with additional workflow engines like Temporal. That's part of the design, right?
That's correct, yes. And in fact, Ryan is going to demonstrate that next after this. We didn't get into that for this proof of concept, but yes, that's absolutely a very important part of the plan.
Right. And so the last thing I will say to any community member who's watching this now, we are going to need help implementing the programming model specific part of this proposal into all of the Dapr SDKs. So if you have an interest to work on this, be on the lookout for issues once this building block comes. And just to set the record straight, this is not going into 1.9, maybe not even 1.10. But we will be updating the Dapr roadmap for when this workflow feature is going to hit.
I have one other question as well, if I can ask. This is Mark here.
Yeah, please.
And that is, you showed how you can use the different APIs that you can call onto, like use the PubSub API for that.
Yes, I did.
There's some limitation on that at the moment, or will I be able to use any of the Dapr APIs inside all of this workflow?
Currently there is a limitation. We have to sort of specifically implement APIs that are compatible with this workflow engine. So for the proof of concept, we have done just service invocation and PubSub, but the plan is to add additional API support as well, so we can cover as much of the Dapr surface area as we can.
Okay, so good way of describing this is that this workflows SDK allow me to stitch together all the Dapr APIs into a coordinated set of activities that are resilient and recoverable.
Exactly.
Okay, I think that's a great way of describing it, because then people can really see that the power of it is, beyond just individual APIs in here.
Mm-hmm. Yeah.
Awesome. Very well said. I'm already writing that down, Mark. Was there another question?
Yeah. So this Balaji. So another quick question. So I did see, Dapr workflows already. It was using a Logic App engine as well. So I did see some in Git repo as well. So is it not going to be supported anymore? So we'll be replacing with this workflow engine as it is.
Hey Balaji, this is Yaron. So I don't know if you've noticed, but we recently came up with a separate organization for Dapr called Dapr Sandbox. And Dapr Sandbox is basically a way for the Dapr project to try and iterate on projects that are not part of the main Dapr organization. And as part of the effort of creating Dapr Sandbox, we actually moved the existing Dapr Workflows project in there because it has been unmaintained for quite a while. And yes, there is no official, we haven't discussed this in the steering committee yet, and there is no official recommendation for this yet, but it might get archived in the future. And so this is something that might happen. And Dapr workflows, what you're seeing here is really an all-in attempt to create a holistic and much more generic workflow building block than what exists today. And as the maintainer of also the Dapr workflows that exists today, I can tell you this proposal is a really good replacement for that. If you want to use the existing Dapr workflow stuff with the Logic Apps integration, ping me on Discord and we can talk about that. But I would really look at what's being proposed here as the future of Dapr and workflows. Does that make sense?
Yeah, okay, thanks.
No problem.
Yeah.
Okay, we do have one more question and then we should probably move on to our other demos we have. But this question is from Renato. He can't actually unmute or post his question for some reason. So his question is around the longevity of Dapr actors. He says he thought that Dapr actors weren't allowed to live long. So he's wondering how actors can monitor long-running workflows. Perhaps he misunderstood how actors are supposed to work. Would you be able to answer that, Chris?
Sure, I can give it a shot, and feel free, other folks, if you want to jump in as well. The way that we sort of ensure that the workflows can be long running is we keep state in the state store. We do use reminders as well, which reminders can be exist for long periods of time to sort of wake up the workflow when there is something that needs to be done, as well as the APIs are going to be invoking those actors directly. And once an actor is invoked, it will wake up, at which point we can then resume the workflow. So actors basically give us all the long running capabilities that we need to implement workflows. So it's really worked out quite nicely. And if I had more time, I would demonstrate sort of a long running 24-hour workflow as well.
I would jump in here and say actors are very much designed for very long running activities. So an actor in itself is like, you could even treat an actor as like a mini little workflow in itself. And so it's designed to run for days, months, even years.
Awesome. Okay, so just in the interest of time, we'll go ahead and pause our questions on the workflow stuff for now, finish the rest of our demos, and then go ahead and pick up any more questions at the end if we have any more time. Okay. Can you all see my screen again? Are you looking at the slide deck?
Yeah.
Awesome. Okay, so next we're going to move more into the workflow API with Ryan. Ryan, do you want me to go ahead and present your slides and then you can share your screen for the demo?
That would be perfect. Thank you.
Awesome.
So I'm going to be talking about some workflow APIs that we've written. So currently there's only 3 different function calls that we have. We are able to start a workflow by passing in the component, the workflow type, and the instance ID followed by start. It's going to be a HTTP post. It allows also passing in a JSON object with additional parameters, and I'll showcase that in a bit. You can also get a workflow, and you can see the API call there, and it's going to return the instance ID, the start time, as well as the completion status of it. And again, I'll demo that. And we also have the capability of terminating a workflow. Next slide, please. So some of the future work we're going to have going on is making the gRPC API, purging some workflow metadata, pausing and resuming some workflows, and also the inclusion of additional workflow components. Currently, we only have temporal as our backend, but for future work, we're going to have the inclusion and incorporation of various different workflow engines. So without further ado, I'm going to go ahead and share my screen, and I'll give you all a little bit of a demo to see what's going on. So on the bottom, we have just a little terminal window, which is going to be used to run the Dapr sidecar on this app. In the top left, we have the workflow demo app that's going to be running. It's just going to be creating a worker through temporal, registering some workflows, registering some activities, and then running. So I'm going to go ahead. I'm going to run the sidecar on this application. We can see that it was able to start off. So we're going to be running a long running workflow activity. And I'll showcase that on the right-hand side of the screen here. So we have our long running workflow over here, which is going to have an activity. And this activity is going to run for as long as we pass in the parameter, and I'll showcase what that JSON object looks like in a second. So it's going to run through this long running activity. It's going to print out, running the activity, how many seconds it's been running, and then also write to a file just to showcase that we can do that behavior as well. So the API calls are going to look like this. I'll scroll over a little bit. So the start one is we're going to pass in a JSON object, which is going to contain some parameters. We're going to have our workflows. We're going to have the temporal component. The name of the workflow is going to be the long running workflow. We're going to have our specific ID, and then we're going to call start on that. So I will quick showcase what the long running JSON looks like. It's the parameters here is the amount of time that we're going to be running through. And then we have our task queue, which is the queue that we're going to be processing this workflow in. So I'm going to go ahead. I'm going to start this workflow down here, the long running workflow. It's going to start. We can see the instance ID was returned, 202 was accepted. And down here, we can see that the activity is running. Another cool part of this that I'm going to showcase right here is over here in temporal, we can see that we now have our long running workflow with the first ID and the status is running. So I'm going to go ahead and do over here is I can start a second workflow to run concurrently with this one. So if we start another workflow with a different unique identifier, save that and start this one. So we'll now see that we have two workflows running concurrently. We have 29, 0, 30, 1, etc. And so if we go back to temporal now, we can see that we now have an additional workflow that is running. So another thing I want to showcase here is that we can get info on the process. So if we get some info on the process, we'll see over here in the response packet that we can see the instance ID that we got the info on. We can see the task queue that it's in. We can see the status is running, and we can see the time that it was started. So now if we go ahead and terminate one of the workflows, it's going to stop that workflow. We'll get a little message here. And no longer do we have the one counter running all the way up over and over and over again. So now if we go back to temporal over here, we can see that the one instance was terminated. Last thing I will quickly showcase in the interest of time is the YAML file that we have. Currently it's in alpha. We have our component name of temporal as we saw in the API call over here. And we just have our host port and the identity. So I know this is a pretty quick demo, but I believe it showcases that we were able to terminate workflows, start them, get info on them, and have multiple workflows running at the same time with the temporal backend. I know that was very quick, so if there are any questions at all, please feel free to ask.
Thank you, Ryan. This Arthur, that was great. So how would you see the YAML looking like for the built-in workflow? Do you think we're gonna have like a workflow.dapr configuration?
That would certainly be one way to do it. Yeah, we can have a workflow.dapr configuration.
Also, can you go back to the YAML?
Of course, yeah, let me go back to that YAML file for you.
Yeah, so just one small comment. You said that it's alpha and you're based on the API version here, but it's important to note that this API version is for all Dapr components, not for temporal specifically.
That's a good point, yeah.
Yeah, that's the API version for the entire schema.
That's a good point, thank you.
No problem.
Any other questions? Going once? Okay. In that case, let's go ahead and I'll steal that screen back from you now, Ryan.
Yep.
Awesome. Thanks for that demo.
Of course.
Okay. Can you all see my screen?
Yes.
Yeah.
Great. Okay. So next we have another demo, but this one's from Diego, and it's going to be on PubSub for actors. Diego, do you want me to go ahead and share your slides?
Yes, please.
Mhm.
Okay. Hi, everyone. I'm Diego. I'm working as an intern for the Dapr team in Microsoft, and my intern project was creating PubSub for actors in the Dapr runtime. So let's start. I brought a simple demo to showcase how you can use PubSub for actors. But first, let me explain a bit of the diagram that I created. So it's like the title said, it's combining PubSub and actors. So you can use like event-driven events to invoke methods for the actors. And you can use this new API with actors, then the actor type, actor ID, publish the PubSub name and the topic, and invoke an actor runtime, well, an actor by the actor runtime configuration. Yeah, in the diagram, you can see that I created a post request. It sends to the message broker, the Redis cache, and Dapr already knows where to host the actor and allocate it. So it will invoke that method directly. So you don't have to do anything, except when you create the actor, you need to include the subscription in the actor runtime configuration that I will show you right now in the demo. So let's continue. Now, I told you that you don't have to include the actor type and actor ID. I don't know if I say it, but yeah, you don't have to. But in the subscription, you'll need to have a matching actor type and actor ID, so the events know where to go. So I created this little flow diagram where an event gets to the Dapr runtime and checks if the actor type is the same as the one that it was declared in the subscription. So if it's not, then continue to the next subscription. And if it is, match it. Or if there is no actor type in the cloud event, then just continue to the next if statement, which is if it has like an actor ID, you cannot include it too. But if you don't include it, you have to include in the actor subscription an actor ID attribute, which is a string that you can use as an ID from the cloud event. And once you match all of the all of the fields of the actor, then you can call that actors method. So let's continue to the demo. I brought this little demo, simple one. So you get like a stock broker application. Let's say that one, Robinhood, which is a bit popular. And you got this cool feature that enables users to sell and buy stock based on the price of that stock. So you get the standard account, which is an actor type, and the premium account, which is another actor type, but it's subscribed to two topics, the stocks and the crypto. And the standard is just subscribed to the stocks topic. So the premium is more premium because it has more subscriptions that can handle. So let me show my screen so I can show you how you can use actor PubSub for actors. Oh yeah, this is the diagram. So I got this. This is like my application. Ignore this part. I used Yahoo Finance to make it more realistic, but it decided to stop working for me right now. So okay, that's okay. So let's say this is your application where you got your price and bidding and a lot of things that are happening here. And well, you sent a request to the publish actor event, which is the new API for PubSub for actors. This is using Python SDK, so it's gRPC, and include the PubSub name, the topic, which is stocks, actor ID. I use the A just to access its state. And I don't want to include an actor type because I will be sending this to two different sidecars with two different actor types. So I don't want to do that. And yeah, so I just send this and wait 20 seconds to send it again. As you can see, it's really simple. I got the price here and just add 2. So that's really simple. Yeah. So in the actor runtime configuration, I've included this new field where you can include the PubSub name that you will be subscribing to, your actor to, the topic, the actor type that will be receiving that event, and the method that will handle the event, right? And this is the optional field that you can include. So if you don't include the ID if you don't include the ID in this message, the event, like this one, you can use this one, this ID to access the event, the cloud event, and check if this ID exists. And if it is, then use that as an ID for the actor. So then I just create that actor and run it. And for the other actor type, I've got this premium account, which is the same thing. It's subscribed to stocks, and it uses this actor type premium account, which is premium actor, and handles price stock. But I also subscribe this to the crypto topic, and it's the same thing, and it has a different method to handle that price, right? So let me just, I'm using here the state store for the actors. It's simple Redis, the one that Dapr includes, and the PubSub is the same, Redis, and this is the name, market price. And lastly, let me show you your application that sends the crypto price. So it's the same thing here. It's just that it's sending like Bitcoin price, but I added here actor type premium actor because I know that that will be the only actor that will receive it. So let me show you how it's done. So this is the premium account, and this is the standard account. I run it. It updates the placement tables and is checking healthy. Now let me run the one that sends stock from Microsoft. And as you can see, both actors received that event. It's doing it's just doing that. If it's higher, then sell everything. It's a simple demo, but as you can see, both accounts have been invoked, and then again, both have been invoked. Now let me add the second service, which is the crypto. And it's the same thing, but only the premium account has received that event. The standard account, it's already, well, it's not doing anything. And now the premium actor is handling 2 events at the same time. So that would be my demo. I don't know if we got any questions.
Okay, I don't see anything in chat.
Thanks. Great demo, Diego. So my question for you is like, I don't know if you maybe forgot that part, but the order is not guaranteed here, right?
Oh yeah, of course. There are some limitations. Thank you for that question. The order is not guaranteed for this implementation for now because we are not waiting for, well, another sidecar is not waiting for other actor or sidecar to finish the processing an event till receiving another event. So if it receives an event, it's processing it, and another sidecar receives another event, it will process it and maybe finish it first. So yeah, order is not guaranteed. And another limitation is that when you send all these PubSubs and the actual runtime is not configured, PubSub will handle retrying, and it will say like it's an error, retrying. And yeah, that will be seen in the when you create the actor as that the actor was not allocated or invoked.
Hey, Diego.
Yeah,
First, thanks for picking up the work. This has been one of the most highly requested features in Dapr since inception. It started in 2019, and we've postponed it for more than 10 releases. So this is really great to see. A question from my side, we've recently enabled dead letter topics. Does this mechanism work with those? So for
No, that their topics have not supported yet. Yeah, it will take a bit more of time and I didn't have for my internship.
Yeah, no problem. This is something that the community or maintainers can pick up after. But it's important to call out as a limitation. And then my second question, which I think I already have the answer for, I just want to be sure. Does this work with the other Dapr PubSub guarantees, like at least once delivery?
Sorry, again?
Does this guarantee at least once delivery?
Oh yeah. It has like the PubSub features. That's the why would we using it? The PubSub. It handles error, one delivery, and consumer groups. So, yep.
So I've taken a look at the PR you opened. It's looking good. Again, for the community, this is not something that's going into 1.9. We will try to get it in for 1.10, if not just for all of the community users who've been banging down our doors with this feature. So yeah, we really want to do well by the community and finally get this highly requested feature in. Thank you, Diego.
Hey,
Thanks.
hey, I've got a question.
Yep.
I may have got this wrong, but when you're publishing that event, is it true that you're using a very explicit publish API method that is specifically for publishing to actors?
Yes, you need to. Well, there's a new API with its alpha 1 suffix. You need to use that specific API, or for gRPC, there's a specific new actor event request.
Okay, so I ask because what would this work in a use case where I publish an event, but my subscribers may be actors and non-actors, just like a normal service? Would this cover both of those use cases?
In theory, yes, because the subscribers are on the other side of the subscription, but you will need to change the publish to have the actor and.
I think just to make sure I understand.
Oh, no.
But if you have to publish, you can't have, just to kind of reiterate that question, in order to call it actor API, those publish events will only go to actors. They won't go to other services that are listening for that topic.
It will, because it's just a cloud event. The information about actor is just attributes of the cloud event. So you could receive that through any regular PubSub subscription in Dapr. So, and it can also, Diego, correct me if I'm wrong, based on your design, you could also publish with a regular API.
Yeah.
But you will need to hard code the actual type at the subscriber side, and you have to specify which attribute of the cloud event corresponds to the actual ID. So you could even use that without the new publish API as well, as long as you have some way to identify the actor ID.
Yeah, this is really
that makes
great.
sense.
And Arthur, I think this really calls out for an end-to-end test that can verify this behavior, that these types of events can be consumed both by actor subscriptions and non-actor subscriptions.
Yeah. Oh, absolutely. And I will go one step ahead. And I would think that unless the community does not require in-order processing, I do think there is a great potential here for us to reuse our implementation for reminders, for us to guarantee single tone subscriptions on the actor side for actor ID. So you could guarantee orders some scenarios. So I do think there is potential to even take this to the next level.
Yeah, that makes sense.
Thank you.
Great question, Oliver. Thank you.
Yes.
Thanks, everyone.
Any other questions? Okay, in that case, let's go ahead and move on to our last demo. I will reshare my screen here. Awesome. Thank you so much, Diego, for that demo. Next, we have Amelia, who's going to go ahead and demo some exception handling for actors. Amelia, are you around?
Yes, I can start.
Actually, I don't think you have slides, so I can just let you share your screen.
Sure, yeah, definitely. So hi, this is Amulya Varote, software engineer from Microsoft. I'll share my screen. I hope you all can see my screen. So yes, today I'm here to present one of the issues that we received recently from one of our users, which is exception from actors method is not surfaced to the caller, which is basically whenever there is a call to the actor method, the exception is quite generic. So let me show you the existing behavior. I built the existing .NET project, and there is a small actor exception project that I'm using here. So I'm starting my callie. And when I call it, if you see here, the details are not displayed. So it just says remote actor method exception, but we don't see any details in here, right? Like which method, line number, and so on and so forth. So let me go to the branch that has these changes, and I'll build the project. Yeah, this should be done quickly. Yeah. So when I execute the same application, so yes. So now if you see, we can see the details as well here, the exception name, the method name, line number, and we're just creating one more information, which is exception UUID, to match the exception both on callie as well as the caller side. So if you see on the callie side, we display the same exception details with the same UUID so that the user can match the exceptions that have been thrown. So so the whole details is again sent to the callie, which is basically the expectation. So yeah, I think it's a pretty small and quick demo, which gives the exception details, which will help the users to start looking to where exactly the exception has been thrown, rather than just telling them, okay, there is some remote method exception. Yep, that's all I have.
And was all the changes done only in the .NET SDK, or did you require to make a change in the runtime as well?
This is just on the .NET SDK side. Yeah, thanks for that point.
Okay, so we need to replicate this on each SDK. Okay, awesome.
Right. Yep.
Okay.
Yeah.
So we had like an actress demo community call today.
Yeah.
Yeah,
Thank you so much. Yeah.
Thank you.
Awesome. Any questions? Any other questions? And these could be questions for anything that was demoed today. So if you have any other workflow or questions on pub sub and actors as well, this is the time to ask them. Okay, seems like everyone's all talked out. So I think we are good to probably close our community call a little bit early today.
Hi, can you hear me?
Oh yeah, we can hear you.
Hi, my name is Saint Thomas. I had a couple of questions regarding the PubSub for the Kafka connector. So my first question is, so I was trying to connect to the Kafka cluster, and so there are three ways we can connect to the Kafka clusters, right? Using SASL, plain text, MTLS, and SASL username and password, right? So SASL plain text I am able to connect, but when I try to connect using SASL TLS mechanism, it's throwing some error. So the way Kafka is configured is using Kerberos principle and key tabs. So whether the Dapr, my question is will Dapr support the Kerberos principle and the key tab authentication?
Yeah, hey, Sam, I'm not sure we have Kerberos authentication support. Did you open an issue on the components contrib repository by any chance with the details and the exception you're getting?
No, I did not. I'm planning to submit the details.
Yeah, I don't have an answer on the top of my head, but if you open an issue, we can certainly take a look at it. I also see Phil on the call. Phil, if you're here, Phil's had lots of experience with Dapr and Kafka. Maybe you can help.
Been a while since I looked at that component, but yeah, I don't think it supports Kerberos.
Okay.
So that would definitely need to be an issue. Okay.
So I'll submit the details, so that you can look into that later. So my second question is, so since SASL with the Kerberos didn't work, so I tried with MDLS authentication by providing certificates. So that didn't work either. So my question is whether the certificate Dapr accepts only in certain formats. So the certificate I do have is .pem format. The question is whether the Dapr only supports or accepts only certain formats. Do I need to convert that PEM certificate into some RSA private key or .cer format? Because in the example, the documentation page, the CA-cert example given is base64 encoded DER certificate, and the client certificate is also base64 encoded DER certificate, and the client key given is the RSA private key, which is base64 encoded Pixie 8. So by saying the sample, I'm just confused, whether it accepts only that format or will it accept other formats as well?
Yeah, I think it'll only accept that format. I'm looking at the docs and what we do in the code actually right now. Yeah, I think that's only what's supported right now.
Okay. Yeah.
Is that an issue? Like, can you not convert to that particular format for?
Yeah, I can convert, but my question is whether it accepts only that format only or not.
Yeah, I don't think PMs are supported.
Okay, I'll try to convert into that format and see. And if
All right.
I still face issues, then I'll submit that question in the.
That might be a good format to support, though. So I would also consider raising that as an issue as well.
Yeah, exactly.
I would raise that as an issue because that PEM format is, as you point out, the more common format. So it would be worth raising an issue to track that, and then we can see if we can get that in there as well as a future issue.
Yeah, sure. Thank you.
I have a question for Ollie. Ollie, did you just change your profile picture to yourself holding a beer?
I did. That wasn't a
Okay.
hint. That wasn't a hint.
All right.
Keen eye, your own. Okay, any other questions, beer related or otherwise? Just kidding. Anything related to the demos? Awesome. In that case, let's go ahead and close this community call. Thanks everyone for joining.
Thank you. Bye.
Okay.
Thank you, team.
Cheers. Bye.
Bye.